All right, so segment three, we're going to talk about acid-base reactions. So there's three different acid-base reactions that you need to know. And the first one is a strong acid with a strong base. That's SASB. That's strong acid, strong base. So example of a strong acid would be HCl. It's a strong electrolyte. It's going to break up into its two separate ions. The strong base in this scenario is NaOH. Breaks up into Na and OH. So in a strong base, strong acid reaction, the only two reacting species are the hydrogen and the hydroxide. So the net ionic equation for this is hydrogen plus hydroxide forms water. Otherwise, the Na ion and the Cl ion are just considered spectator ions. They never change. So in your reaction, what counts is what changes. So in this case, it's the hydrogen and the hydroxide that turn to water. That's the neutralization reaction. The next neutralization reaction is a weak acid with a strong base. And in this scenario, we have this weak acid that has this double arrows again, which I showed you in the first segment. And I have the hydrogen ion, and this would represent the benzoate ion. So this HB is the molecular form of the acid. So that's always going to be present. And then the strong base is represented by just the hydroxide ion. So a typical strong base, something like sodium hydroxide. And I would show now that what happens is that really, so down here below this horizontal line, I have the molecular form of the acid, the benzoic acid, reacting with the strong base to leave behind the benzoate ion and form water. So the change that undergoes here is that the hydrogen ion that's loosely released, in other words, not a very large percent of ionization here, it is going to end up getting canceled out. So the small amount of that gets ionizes is insignificant. So instead, what happens is that the hydroxide pulls the hydrogen um, pulls the hydrogen away from the benzoic acid, leaving behind the ion and water. So this is kind of the best format to help you remember what happens. That is the strong base that reacts with the molecular form of the acid. And then conversely here, we have the strong acid reacting with the weak base. So in this case, the weak base is the ammonium ion. The ammonium ion actually reacts with water to form the ammonia molecule reacts with water to form the ammonium ion and the hydroxide ion. But what happens is that the hydrogen ion from the strong acid reacts with the hydroxide to form water. And so if we look at this as hydroxide's being produced here, being used up here, water's being reacted here, produced here, so they cancel out. If they're on opposite sides of the yield sign in the reaction, then they're going to cancel out. So very similar to the one above, the molecular form of the weak base reacts with the hydrogen from the strong acid to form the ammonium ion. So this hydrogen gets pulled in to that. And that's what's going to happen in all of your strong acid weak base. That's going to be the major reacting species that reacts with the weak base. Just like up here, the major reacting species is the hydroxide from the strong base. In this case, it pulls away the hydrogen and creates that. And then on the next page, I have some other examples for you to try. And so I would say take a moment now to try these examples, I have this worksheet in the practice worksheet folder. So try those examples for a minute and then come back and look at the answers.